You know, in the world of AI, there's this mantra you hear all the time. Bigger is better. But what if that's, well, just flat out wrong? Today, we're digging into a fascinating story about a tiny AI that can outthink the giants, and it challenges the very foundation of the current AI arms race.
For years, it really seemed like the answer was a definite yes. The whole strategy was to just build larger and larger models. But what if that isn't the whole picture? What if, for some really crucial tasks, the exact opposite is true?
So right now, what we're seeing in AI is this massive arms race for scale. All the big companies are pouring billions into creating these enormous large language models, or LLMs, all based on the belief that more data plus more processing power automatically equals more intelligence.
And just to give you a sense of the scale we are talking about, a massive model like Grok 4 reportedly has something like 1.7 times trillion parameters. Now, you can think of parameters like the little knobs and dials the AI uses to learn. This is the Goliath in our story, the absolute poster child for the bigger is better philosophy.
But here's the thing. These giants, they have a critical weakness, a massive blind spot that becomes crystal clear when you stop asking them to write a poem and start asking them to solve problems with pure, hard logic.
And this is where things get really weird. As you can see here, LLMs are incredible conversationalists. They'll write an essay for you, summarize a long article, no problem. But then you ask one to solve a truly difficult Sudoku puzzle or a tough logic problem, and they just fall apart. I mean, they fail spectacularly. So what gives? This quote from the source material really just hits the nail on the head. See, LLMs build their answers one piece at a time, one word or token at a time. For something like a logic puzzle where every single step has to be perfect, well, if just one of those tokens is wrong, the entire solution just collapses. There is zero room for error. Okay, so naturally, researchers started thinking there has to be a better way, right? And the first big attempt to solve this problem was a model that was, let's say, very clever, but also incredibly complex.
It was called the Hierarchical Reasoning Model, or HRM for short. The big idea was to try and mimic our brains using this recursive process to think about a problem, refine its answer, think some more, and so on. It definitely showed some promise, but boy, it was not simple.
So, why was this thing so complicated? Well, for starters, it used two completely separate networks that had to somehow work together, which is just not very efficient. Then, the whole concept was based on some pretty shaky arguments about how our brains might work. And to top it all off, to even get it to run, it needed this complicated mathematical shortcut. But here's the real kicker. That shortcut only worked if the model's thinking eventually settled down, which, a lot of the time, it just didn't. It was like a beautiful machine built on a really wobbly foundation. A fascinating idea, but just not reliable. And that, my friends, brings us to the hero of our story, a new model that took that core idea of thinking over and over again and just stripped it down to its most simple, elegant, and powerful form. Let's meet the Tiny Recursive Model, or TRM.
The way TRM thinks is just so elegant. It's almost beautiful. Think about an artist making a sketch. First, they make a quick, rough guess. Then they step back, they look at it, they think about it, that's the recursive reasoning part, and then they make a change to refine the sketch. TRM does the exact same thing, just digitally. It loops through this think and refine cycle over and over and over until it's absolutely confident in its final answer.
All right, the stage is set. We've got the complicated older model and this tiny, sleek new contender. But how do they actually perform when you put them to the test? This is where it gets really good.
And the results? Honestly, they are just jaw-dropping. Look at this. On a test of extremely hard Sudoku puzzles, our tiny TRM model gets an 87% accuracy. Its complicated ancestor, HRM, just barely passes with 55%. And the giant LLM, DeepSeek R1, a flat 0, a big old goose egg. It could not solve a single one. Not one. And believe me, this was no fluke. On the ARC-AG test, which is a set of abstract reasoning puzzles that are pretty easy for us but notoriously brutal for AI, the same pattern emerges. TRM comes out on top again, beating both its predecessor and a top-tier LLM, Gemini 2.5 Pro.
This scorecard right here, this is the David versus Goliath moment, and it says it all. Just look at the number of parameters. TRM has only 5 million. DeepSeek has over 670 billion. That means it's more than 130,000 times larger. And yet on this kind of task, its performance is infinitely worse. This isn't just a metaphor anymore, it is a literal David and Goliath story playing out in silicon.
So the big question is how? How is this even possible? How does a model that is 100,000th of the size pull off these kinds of incredible results? Well, the answer is all in its hyper-efficient and elegant design.
So what's TRM's secret sauce? It really comes down to pure, elegant simplicity. It uses just one tiny network, not two clunky ones. It has fewer layers, and most importantly, it throws out those unreliable shortcuts. Instead, it learns by looking back through its entire chain of reasoning. It's like a student showing their work on a math problem. It learns from every single step, not just the final answer. This direct approach makes it way more effective, and it avoids a huge pitfall in AI called overfitting. That's when a model just memorizes answers instead of actually learning the method. TRM learns the method.
And that's really the crucial point here. TRM's success isn't just some cool party trick for solving Sudoku. It's a proof of concept. It suggests that the real path to more powerful AI might not be about brute force and just making things bigger, but about designing systems that can reason more efficiently, more elegantly.
This completely flips the bigger is better idea on its head. It really forces us to ask a tough question. Are we building truly intelligent systems, or are we just building incredibly large parrots that are getting better and better at mimicry? Because maybe, just maybe, the future of AI won't be won by the biggest model, but by the one that has truly mastered the art of thinking.